is CORDIScovery. Hello and welcome to this episode of the CORDIScovery podcast with me, Abigail Acton. Economies will struggle to get back on their feet in a post-COVID pandemic world, and the aviation sector will undoubtedly have a key role to play. But how do we tackle the great dichotomy? Flights are crucial to GDP, but flying damages the environment. Can we take to the skies while still meeting the objectives of the Paris Agreement on climate change, or the EU's goal to be carbon neutral by 2050? And do those living near airports want us to go back to business as normal? Today's three guests, whose work was supported by the EU's Horizon 2020 programme, may just have some answers. Making hydrogen-fueled flights a reality, redesigning aircraft wings to reduce drag and increase fuel efficiency, and fully understanding local residents' perceptions of noise when designing airports or building new runways, or simply wanting them to have easier, more comfortable lives in the vicinity of airports. Welcome to a futuristic episode of CORDIScovery with Dr. Andrew Rolt, Senior Research Fellow at Cranfield University, who is researching technologies for liquid hydrogen-fueled commercial aviation. Andrew is involved in the Enable H2 project. His areas include technology assessment, hydrogen combustion, and road mapping a transition to hydrogen. Welcome, Andrew.
Hello, everybody.
Dr. Vittorio Cipolla, Assistant Professor at the Department of Civil and Industrial Engineering of the University of Pisa, is focused on aircraft design with an emphasis on disruptive architectures. Vittorio was the coordinator of the Parsifal project, which designed and analysed the potential impact of a new box-wing design on aviation. Welcome, Vittorio.
Hello, Abigail and everyone.
Dr. Laurent Leylekian, European Affairs Officer at ONERA, the French aerospace lab. Laurent is an expert in aviation noise reduction technologies and strategies and the coordinator of the ANIMA project, which provides authorities and airports with suitable management and mitigation procedures to reduce the annoyance experienced by local residents relating to noise pollution. Hello, Laurent. Thank you for joining us today.
Good afternoon. Hello, everyone.
Andrew, if I could turn to you to start with, the first thing to address head-on is the possible preconception that hydrogen fuel isn't safe. Can you explain why, in fact, it is?
Thanks. Yes, we get this question a lot, and addressing safety concerns is a major aspect of the Enable H2 project, even though hydrogen already has an excellent safety record where it is used today. For example, hydrogen is widely used as a feedstock in the chemical industry, and it is used to cool electrical generators in power stations. And now that so-called green hydrogen, made by the electrolysis of water using renewable energy, is rapidly becoming affordable, we see hydrogen being used as an energy carrier and replacing fossil fuels in all kinds of applications, from domestic heating to ground transport. These are all areas where we want to eliminate CO2 and where safety is vital. This is why Airbus believes hydrogen-fueled net zero airliners could be entering service in about 15 years' time. This should not only address global warming, but also improve the air quality around airports. Like any fuel, hydrogen will burn, but it does so quickly with relatively little radiation and no smoke. And I'd just like to note that in the major airship disasters of the 1930s, it was actually the fuel oil, not the hydrogen, that sustained the fires.
That's very interesting because obviously when we think of those ghastly images, it's that we think of it as being the hydrogen that went up and not the fuel oil. So it's an important point to note. So I understand what you're saying clearly, that it is perfectly safe, and as you say, it has applications in industries and where safety is obviously of the essence. So we can understand that is the case. But then why should we be working so hard to make liquid hydrogen a viable alternative to fuel beyond the fact that it's safe? What are the benefits?
Well, some small research aircraft are using compressed hydrogen gas in fuel cells for electric propulsion. But gas tanks weigh more than 10 times their contents, and this will limit the aircraft ranges to 1,000 kilometers or so. That still beats battery-powered electric aircraft, but for longer ranges, aircraft will need to carry a lot more fuel, which is where liquid hydrogen comes in. It's denser, and it can be stored at low pressure in much lighter tanks. This makes flights of 5,000 kilometers or more feasible, but the tanks must be well insulated because liquid hydrogen boils at minus 252 degrees C. That provides some challenges, but also opportunities because the cold hydrogen can be used for cooling functions on the engines. Chalmers University is studying the best ways to improve aero engine efficiency using heat exchangers that would also be warming up the hydrogen on its way to the combustor. And at Cranfield, we're modelling and rig testing a novel micromix combustor concept. Our aim is to demonstrate high combustion efficiency with very low NOx emissions. NOx and water vapour are the only direct emissions produced by hydrogen, but together with contrails and contrail-induced cloudiness, they can still contribute something to global warming.
So, I mean, contrails as a contribution to warming is obviously a major concern when it comes to the aviation industry. And if hydrogen is still producing the contrails, I understand the benefits that you just identified and the weight and so on, but how can we mitigate the effect of the contrails? Are they preferable in their nature somehow to traditional fuel contrails?
Well, yes. We believe the contrails from hydrogen-fueled engines will be less opaque and so will have less warming effect. In other words, they won't stop the Earth radiating away heat. Because unlike kerosene, which is our current aviation fuel, hydrogen won't produce the carbon and sulfur containing particles that act as nuclei for the formation of contrails and cirrus clouds. Modern aero engines have very low oil consumption, but the oil will still generate some particles. So more research is needed because there's still a lot of uncertainty about contrails and their effects on the Earth's heat balance. Contrails only form under certain atmospheric conditions, and they can generally be avoided by flying at different altitudes. Another possible approach might be to extract water from engine exhaust when flying at high altitude.
Right.
The effects of contrails are very short term, but CO2, on the other hand, stays in the atmosphere for many decades, so its greenhouse effects are still seen to be a bigger concern.
Right. Okay. With regards to the reduction in weight, obviously that makes the planes more efficient. And I know, Vittorio, efficiency of the flights and the airplanes themselves is something that Parsifal's been very interested in. I know that you were considering the impact of the reduction in fuel consumption by your new design, which you estimate to be almost by 1/4. So I presume, obviously, hydrogen must also be interesting for the Parsifal project.
Yes, exactly. Thank you for this question, Abigail. It's actually our next step. Now we have studied which are the improvements that can be provided by just changing the aircraft architecture without taking new fuels or new propulsion systems into account. So, and we achieved the results that you have anticipated. So the next step is to take alternatives like hydrogen fuel or hybrid electric propulsion system for smaller aircraft, for example, into account and see which will be the combined result.
And that being the case, would you have any questions that you would like to put to Andrew? Or also, Laurent, if you have a question you would like to put to Andrew?
Yeah, maybe a couple of questions, at least one. It's a very, teasing hypothesis, this hydrogen combustion. But I would like to know, in the case, if we make the assumption of a massive conversion of air traffic to hydrogen, do you have, or do we have any assumption or any hypothesis on our ability to cope with the demand of hydrogen? I mean, facilities to produce this new fuel is not here at the moment, and so I would like to know if it's still considered.
Yes, it's a good question. The introduction of hydrogen obviously won't happen overnight. We're not going to suddenly convert the engines to run on hydrogen. It will need new aircraft, new engines, and it takes 20 years or more to replace a fleet of aircraft. And initially, obviously, hydrogen will be not the only fuel that's being used to reduce emissions, because we also have sustainable aviation fuels, biofuels, and so on, which will play a role. So I think that we will see a development of the hydrogen economy, which will make hydrogen supplies and piping hydrogen to gas to airports relatively straightforward. And then in the next phase, we will look to introduce hydrogen liquefaction plants and storage facilities for liquid hydrogen. So it will be a build-up over 30 years or so.
Thanks, Andrew. Thank you very much. Yes, that was a good question. Vittorio, if I could turn to you, since we're talking about greener fuels or ways to reduce emissions and so on, obviously energy efficiency is a key point to this. Can you tell us more about this interesting design that you came up with regards to a box wing concept?
Yes, sure. So in Parsifal project, we studied the application of the box wing configuration to short and medium range aircraft. So this configuration comes from an idea of 100 years ago by Ludwig Prandtl, which is one of the father of aerodynamics. And he came up to this concept he called best wing system, meaning that this was the system capable to maximize the span efficiency, which is one of the most important components of aerodynamic efficiency, without increasing the wingspan. So if we think to today requirements of reducing fuel consumption and reducing the environmental impact, one of the possible approaches to improve the aerodynamics by acting on the aircraft configuration. Traditionally, this is done by increasing the wingspan of aircraft, creating bigger aircraft, basically. But this is in conflict with the airport constraints, since it increases the level of saturation. So the solution we propose in the Parsifal project is to adopt the box wing technology to increase the aircraft aerodynamics without this increase in the wingspan. And not only, in particular, we decided to exploit the higher aerodynamic efficiency of the box wing by improving the number of passengers. So we didn't focus on the increase of speed or have a longer range, for example, but we wanted we set as requirements to have an improvement of about 50% if compared to current Airbus A320 or Boeing 737. So although Prandtl's idea is not that new, we anyway came up to a disruptive configuration since it is revolutionary. And as a result, in terms of fuel consumption per passenger, the reduction ranges between 12 and 22%, depending on how many disruptive building blocks you take into account. So basically, there are several opportunities for exploiting this configuration.
Well, that sounds absolutely fascinating. I love the idea of the fact that you're taking something that's historic and it's now becoming disruptive. It's true that when we think of old box wings, we think of the past, but I've been seeing some of the images of your prototypes and your design concepts, and they look very futuristic, actually. So industries have in the past been reluctant to embrace disruptive solutions. Also will have an impact on the uptake of hydrogen, I imagine. But what do you think is a key motivator for change when it comes to rethinking old ways of doing things? And how is Parsifal trying to get the bigger players on board? How is industry being persuaded?
Yeah, sure. So aeronautic industries are, of course, reluctant since there are billions of investment needed for such a change. And even having the money, anyway, the time to market for such kind of projects are very long. We're talking about 20 or years, maybe something like that anyway. So the key motivators for such a move probably is yet to come, but I think that the seed is already there. And I'm talking about the effort to protect the environment, which can leverage on industries. So not only about aeronautics, but generally speaking. And this can happen, I think, in two ways. The first one, which is more direct, I think, is what today we call green taxes. So basically, these taxes make more competitive those companies which invest in green solutions and protect the environment. The second way is more indirect, I think, and is the customer's choice of giving their money to companies which put their effort in protecting the environment.
It's certainly the case that consumer pressure really does speak now more than ever.
Yeah, sure. And I think that once both these two phenomena will grow enough, they will be big enough, so the industry will be somehow forced for such kind of change. So our solution is not the only one, of course, is one of the possible, but now we are studying also how to apply to other configuration, other categories, and prototypes and other validation are ongoing, and the industry is very interested on our results.
Fantastic. That sounds excellent. And it's true that once they realize that they really have to find a solution, then they cast around to see what's out there as concepts that could work. And there you will be in a perfect position to show them an idea that would work. Does anybody have any questions here for Vittorio? Laurent, do you have any questions about noise, actually, Vittorio, I'm thinking myself, what is the noise factor of your new design? Sorry, I'm asking your question for you, Laurent. Forgive me.
Okay, I can answer if
Yeah, please do answer.
Okay, so yeah, we also consider the environmental impact also on not only on the emission side but also on the noise side, and we came up to good encouraging results. But since we didn't consider new propulsion systems, what the result we obtained is something that is to be compared to the increase of passengers we can produce. So basically, we can have this airport of the same size with a similar level of noise, but the passenger capacity will be highly increased. So in a scenario in which the air transport is growing, this is in a way, from our perspective, of course, a good solution to limit the growth also of the noise associated to the traffic growth.
Thank you, Vittorio. Maybe just one remark and then a question. The reluctance to operate such aircraft is not only from industry, but also probably from airlines, because there are some psychological factors that would prevent maybe some customers to embark in these new kinds of aircraft. That's also a factor to be taken into account, certainly. As you mentioned noise, and of course, Abigail raised the point, I would like to know if you also embark in the kind of comparison with other futuristic design, like the so-called blended wing bodies aircraft, not only about noise, but maybe also about the lift-to-drag ratio or this kind of factors. Certainly you did.
Okay, so on the airline side, we involved some airline company managers in the advisory board of the project. So we try to anticipate some of these kind of issues, not all this one. And we did the same also with the industry experts and also airport management companies. So we put together all the constraints and possible issues arising from the introduction of this innovative concept. And so we've taken all these aspects into account. Concerning the second question about the comparison, we acted in a more traditional way, comparing the new solution with the state of the art. So in Parsifal, we achieved all results which have a value in terms of comparison with what we should expect in the future if we assume an evolution of the conventional configuration. This is the approach that we developed. It will be interesting also to perform, of course, a comparison with other alternatives. But probably the final answer is that we need both. I think they are very specific for the missions that you take into account, and they are very different.
It's interesting that you say we need both. It's what Andrew was saying earlier about the necessity for a range of options for fuel as well. In other words, there isn't just one silver bullet. It's interesting to apply as many new concepts as possible to try and resolve these issues. Thank you very much, Vittorio. Laurent, if I could turn to you. So far, we've been talking about engineering solutions to emissions and engineering solutions to fuel efficiency and so on. I know the ANIMA project has been considering another form of pollution, namely noise pollution, but you've been thinking about the problem from the perspective of local residents. Why not leave the issue of noise annoyance to the engineers?
Well, because the solution is not only up to the engineers. So far and for years, the issue has been taken and dealt with by engineers, with some successes with regard to the objective put forward by the ACARE and by the European Commission. But we are now saturating, and there are some legal issues and also some regulatory issues, and also some issue related to the society that makes the problem more holistic. And to solve this problem, we need also to take into account the attitude of neighboring residents toward aviation and toward aircraft. And so we made more than half of the path with engineers, and now we are in need of the other stakeholders to make the other part of the path.
And how are you establishing actually what their feelings are? What is the work of the project with regards to getting people's opinions?
Well, in the project, we made first a review, a very comprehensive review on how airports have taken into account the regulation, which is very complex, with multiple stack, multiple level. and also how they try to implement some mitigation measure, how they try to engage with their neighbors when it failed and when it has some success. And then we also try to understand what means annoyance, because annoyance is a kind of very catchy word, and behind this word there is a very wide set of concepts, from just being annoyed when you're reading a book up to difficulty to learning for children, or up to even some very physical effects such as strokes or strokes, for instance. And so we put the emphasis on what we call non-acoustical factors, because we know, and we knew before, by the way, that noise correlates only to, let's say, a third to annoyance. The objective noise correlates only to a third to annoyance, 2/3 being explained by either personal sensitivity or by some non-acoustical factor, which are something much more in connection with social behaviors.
Okay. It's interesting because some people might find volume more problematic. Other people might find irregularity, a lack of predictability, a problem. Is that the sort of thing your project was uncovering?
Exactly. You're tackling upon metrics, how to measure noise. Of course, for certification purpose, there is some very clear engineer-based way of measuring noise. And also for regulatory purpose, there are some other average noise maps. But when you are living here and then you are not sensitive to an average value, you are sensitive to an instantaneous value. For instance, during night, you are awakened by a given noise and not an average value. So it makes no sense. And indeed, we, to some extent, discover that, or at least we not discover, but we show that to step forward, we need to find not a solution, because there is no solution, but a consensus. And to reach this consensus, we have first to establish a dialogue between all the stakeholders, airport, authorities, the economic stakeholders also, because airports is also economy, is also job, is also business, and also the resident. And the dialogue must be fair, so comprehensible for each of the people without jargonizing. And also the prerequisite for this dialogue is that the promoters of the dialogue should be ready to endorse the conclusion. And this is not always the case.
No, I can imagine. I can see that people will open the door to have these kind of discussions and then maybe turn away from the results of those discussions themselves.
Yeah,
yes,
exactly.
Yes. Do anyone have any questions for Laurent? Yes, Vittorio.
Yes, if I can. So a question which is somehow related to my previous answer. So Laurent, in your opinion, assuming that the air transport will grow in the future, so on the community noise side, would it be better to have more flights per day with more silent aircraft? So maybe bigger airport with more flights, or on the other side, it would be better to have airport as big as the one we have today, but with the higher capacity aircraft, like for example the Parsifal case is this one, that may not be more silent, but in the end you can have less flights per day, for example. So on the metrics side, which would be better, if possible, to have a quick, easy answer on this?
That's a very, very topical and very interesting question. It depends, because for the very same pattern of traffics, in some area people are complaining, and so in some other people are not complaining, and it depends on the local sensitivities. And it also depends on what you are talking about. If you are talking about night noise, probably people would like to prefer something which is high background noise, high level of background noise without any peaks, because you are awakened by peaks. But if you are talking about daytime noise, then peaks are less problematic than the average background noise. So really, the strategies to mitigate noise should be in a local place. should be defined by all the stakeholders together. And for instance, I know that in Australia, they decided to make the takeoff in given direction and in changing direction in order to turn around the airport so that each community will be affected during the whole year, but not always the same community affected every time. So, but this is one strategy, and some other prefer to focus the traffic always in one direction to avoid to spread over the whole area. So I have no definitive answer. The answer is to the local resident, indeed.
Again, we seem to come back to the idea of the fact that there has to be various ways of tackling the same issue. We found it with the fuel sources. We found it with the designs of the airplanes to make them more efficient. And now also with regards to the notion of noise nuisance, it seems that really the answer lies in remaining flexible and thinking out of the box, apparently. I have one more question that I'd like to ask each of you in turn, just a short, simple answer. And I'd like to start again with you, Andrew, if I may. What do you feel in your field will be or should be the key innovation embraced by the aviation industry over the next decade? Tricky question, huh?
Well, I'm going to say that we will be starting to move away from using kerosene as a dominant aviation fuel. And in the short term, we'll have sustainable aviation fuels and then a transition to hydrogen beyond the next decade.
Excellent, Andrew. Thank you very much. And no doubt Enable H2 will be part of the reason for why that becomes feasible. If I may ask you, Vittorio, what do you think will be the innovation?
Okay, I think that I could mention a lot of technology enablers that are worth to be studied. But I think that most of the innovation should be on the side of the process of collaboration between the industry and research center, because there are a lot of enthusiasts among the industry experts that maybe are not very well encouraged to push on the innovation side. So I think that if industry starts to create kind of innovation department where they should be seen as an aspired career goal for people from industry, I think that innovation will be boosted tremendously.
Thank you, Vittoria. Excellent. And Laurent, so in your field, what do you think should or will be the key innovation in the next 10 years?
Well, I suppose that the key word should be intermodality, because at the time being, we have big hubs which are concentrating all the problems, noise, pollution, congestion. And so probably we will have less traffic at short distance, and also a traffic which will be more distributed directly from small airport to small airport rather than concentrated to big hubs.
Yeah, that's an interesting idea. And it's more accessible as well.
Yeah, more direct and maybe more respectful with regard to noise and pollution.
Well, thank you very much. That was very interesting. And I found particularly fascinating the notion that there needs to be a variety of solutions to each of the problems or considerations that you have all been focusing on so successfully in your projects. Thank you very much for your input. It's given me something to think about, and I'm sure also for our audience.
Thank you, and see you then. Thank you.
Yes.
Thank you, Abigail.
Thanks a lot. Thank you for your invitation.
You're very welcome. Find out what other projects funded by the EU are working on to ensure the aviation sector remains robust by taking a look at issue 99 of the Research EU magazine, The Future of Aviation, The Only Way is Up, available on the CORDIS website, cordis.europa.eu. The website offers you the chance to see what's being achieved by EU science funding, from short daily news articles through to more in-depth analysis provided by the magazine and results packs. These bring together projects that are researching in the same domain to show the scope of work being done. If you're more interested in interviews, the Results in Brief section explores research through the eyes of the researchers themselves. And if you think you have a project that could benefit from EU support, the site will show you what others are doing in your field. So come and check out the research that's revealing what makes our world tick. Our next episode will consider the new synergies of shopping, e-commerce or bricks and mortar. Does the high street have a future, or has the COVID pandemic simply accelerated an inevitable shift to online shopping? Join me to hear what 3 leading researchers in the field can reveal. We're always happy to hear from you, so drop us a line, editorial@cordis.europa.eu. Until next time.